Okay. All right. We'll be dealing with interval notations today. First of all, let me describe this right here. This is what we call set notation. This set notation is x is less than or equal to 5. Graphically, what does that mean? These are all the numbers starting from on the number line at 5. And this is less than, so the line goes back. So this is the graph that represents x is less than or equal to 5. Now, some students get the less than and greater than mixed up. Let me give you a little way of knowing which one is which. Let's write it right here. This is the less than and this is the greater than. Again, easy to mix up. The less than looks like an L for less, and the greater than doesn't look like the less than. So whenever you see this shape right here, it looks like an L, that's your less than. If it doesn't look like an L, it's the greater than. So this is a less than. So x is less than or equal to 5. The graph of that goes to the left for 5, and we color in the endpoint. Now the interval notation, you can see best from looking at the graph. On the left, since we're headed to negative infinity to the left, we say parentheses negative infinity to the left, comma, stopping at 5 to the right, and this bracket represents the closed circle. So this is the interval notation, and this is all saying the same things. This is your set notation, your graph notation, your interval notation. It's just three things saying the same three things. Same three things. Maybe like language. This could be English, this could be Spanish, this could be Chinese. Okay, once again, here we have x is greater than negative 4. The graph of that will be open at negative 4. That means negative 4 is not being used. And since it's greater than, we're going to go to the right. And that's the graph. Now, interval notation, if I can look at the graph notation, I can see to the left, I'm only going as far as negative 4. But since I'm not getting there, I'll still use parentheses because it's not filled in. And to the right, I'm going forever positive. So that's represented by positive infinity and then a parenthesis here. So again, all three of these things are saying the exact same thing. There's just three different languages. Okay. Now let's look at this one. We're starting off with the graph 5 and then to the right. So the set notation for this would be, let's see, this would be 5 and then greater. So this is x is greater than or equal to 5. And that's the set notation for this instance. Now, interval notation, what I would do is I would say to the left, we actually stop at 5, okay? But to the right, we keep going on forever, infinity, positive infinity. So again, we have the graphic, we have set notation, and we have interval notation. All three of these are saying the same things. Okay, another one. Okay, here's our graph, and we want the set notation for this. Well, this is negative 4 and anything less than. So I'll say x is less than, not equal to, negative 4. And that's our set notation. Furthermore, the interval notation to the left would be parentheses negative infinity. Okay. And to the right, I go no further than negative 4, but it doesn't include negative 4, so we'll use a parentheses. And that's your interval notation. Again, all three of these are saying the same things. Okay. Here we start off with interval notation. We're asked for the graph. The graph for this would be at 2, and it will be solid because 2 is included. And this is infinity, positive infinity to the right. So there's the graph. So 2 included, everything to the right. Now the interval notation for this would be on the left side we'll have a bracket at 2, and on the right we'll have positive infinity. Okay. So these three are saying the same things. Okay. Number 6, we have our interval notation. The graph of this is we have -4, and we'll open circle at -4 because -4 is not included. And this is to the left because it's negative infinity, so we graph here to the left, and that's finished. Okay. Now the set notation that represents this would be x, always on the left side, is going to be less than -4. Finish. Okay, starting with the number line. Okay, this is a number line that is missing the number -4. Okay, so we have all numbers except for -4. So how do we represent that? First, I want to represent that as a interval notation first. So interval notation is this. Let's move this over a little bit. So the interval notation represents this side right here, which is from negative infinity to 4, parentheses, that represents all of this side right here, all the numbers here. Then I union all the numbers that are represented on this side. The numbers represented on this side would be -4 with the parentheses to positive infinity. Okay. So this has to be represented by 2 intervals or notation with a little union here. Now, let's do the set notation. The set notation would be, what represents this would be x is going to be less than 4. And let's see, yep, that's it. X is less than 4. -4. I got my little negative there. Okay. Then, or represents the union here. X would be greater than -4. Okay. So these two represent this line with a little point missing. Okay. All right, number 8. We have a line segment here, and this needs to be filled in. Okay, so how do we represent that using interval notation? The interval notation for this would be 4, not included, and all the numbers after 4 to 6, but include 6. This is the interval notation for this. Okay. And then the set notation is a little strange. Okay, instead of x on the right side, what represents line segments would be x within between 4 and 6. So not equal to 4, but up to equal to 6. That's why this one has a line here and this one doesn't. Right. So all three of these are representing the same things.